Hello, everyone. Can you see my screen?
Yes, yes, we can.
Hello, everyone, and welcome to Sustainable Development Goals as presented by Tinti. We worked on creating an SDG classifier model for shell data. Our project outline will take you through an introduction where we'll tell you all about the SDG goals. Next, we'll take you through an analytics insight where we will look deeper into the data provided to get a better understanding of the task at hand. We did a lot of data analysis. We derived some visuals and used the outcome to guide the direction that our project took. Next, we'll take you through our project architecture, where we'll show you what steps we took in order to come up with our final product. Next, we'll give you an application demonstration, where we'll show you what our final product looks like. And lastly, we'll give you some insights on what we learned during this process. Call it a pros and cons of some sorts. Our introduction. There are 17 Sustainable Development Goals, which were signed up by 193 United Nations member states in 2015. These goals act as a guide for achieving a better and more sustainable future for both mankind and our planet. These goals were born of the success of the Millennium Development Goals. These were geared towards creating a sustainable environmental, political, and social future. These goals were met, and as such, we are enjoying the fruits of this labor. And with that in mind, we are hopeful that the 17 sustainable goals can also be achieved. Since at the moment, we are being faced with a range of global challenges, environmental, social, equity, and poverty that are threatening the very existence of all of us. We need the SDGs to be achieved for a better future for all of us. Our problem statement. It is the aim of all the stakeholders to take social responsibility to ensure that all the SDG goals are being achieved. Our goal is to create an application that will help the stakeholders be accountable in an easier manner. As it is, and also time consuming. It's an exhausting task and also time consuming. It's also prone to human bias, which is influenced by our personal experiences and our opinions. To eliminate these, we set out to create a machine learning application. As it is, most countries at the moment have a lot going on with the current inflation crisis, and an application that does not require human intervention, time or money, is the exact headache relief we all need. With this in mind, we have developed an application that classifies text into their corresponding SDGs. For this project, we solely concentrated on the shell data, since there are a lot of stakeholders and an immense amount of data, and all of it could not be put into consideration. But worry not, any other sort of text that is given to our application will be able to classify accordingly. With those few remarks, I'll hand it over to my colleague Emmanuel to take us through our analytical insights.
Thank you, Rachel, for the insights into the project. Now, for the analytical aspect of it, we first look at the data preprocessing, since the project is database. And our data was a structured one, which consists of rows and columns. And for the columns, which we also call features, we have various features in our test data sets, such as the document ID, the articles, but the important ones are the texts, which are the particular articles that we are trying to classify into one of the SDG goals. So the next column we have is also the SDG labels, which are in numbers and are corresponding to the SDG goals that we have. Then we also have the negative and the positive label. This was achieved by those that compiled the data set by taking each of the articles through some surveys, and the people are told to align or to agree if the text was actually labeled correctly or not. Then the agreement score was calculated based on the negative and the positive label. Then for the cleaning aspect of the data, we went ahead to filter out text where we have more negative label than the positive label, so that we can have a more rigid and integrity data set. Then we went ahead for the cleaning, and in the cleaning we did the normal natural language processing type of cleaning, where we remove all forms of punctuation marks, the numbers, symbols, and other types of noise like hyperlinks. Then after cleaning, removing all those noise, we went on to do lemmatization. And basically what that means was we tried to remove redundancy in the text, so that when we have plurals, when we have singulars, when we have continuous or past tense, we can make them into one meaning. So, but before we did the lemmatization, we did a part of speech tagging. That is, each of the text we align to one of the part of the speech, such as noun, pronouns, adverb, so that when we do our lemmatization, we can have a better result. So after the cleaning, general cleaning and the lemmatization, we went ahead to explore the data set. And the first thing we did was to check on the SDG label, which is our predictor, our target variable, and the SDG goals that we are working with. And if we look at the graphs that we have here, we can see vividly that the data set is not balanced. And we can also see that gender equality, quality education, good health and well-being are more talked about than any other of the SDG goals. And we take into account the data imbalance when we get to the modeling aspects. Then moving on, we try to look at the countries that are more involved with these SDG goals, since the countries are more or important stakeholders when it comes to achieving these SDGs. And we extracted them from all the text in our data set, and we use that to make a frequency graph. And we see that Mexico, China, India top the list in the countries that are more involved with SDG goals. And for instance, when we talk about Mexico, they are the first country to actually pass a law in favor of climate action in 2015, so that they can achieve it by 2020. Then when we talk about China, in 2021, they have a high increase in climate action. And we think that was why most people are talking about China and how they are contributing negatively to the climate change. Then we have India and the rest of the countries. So those are the insights we can get from the text and the countries that were extracted from it. And then moving forward, we try to look at all the words, all the tokens, as we say it in data science, all the features that we are going to be working with in our model. So we use a word cloud to visualize this so that we can get as much words to see. And when we look at it, we have more visible words such as women, gender equality, men, and these are particular words or important features that our model are going to be used to actually classify an article or text to be one of the SDG goals. And we also did that for two more of the SDG goals, which are the top SDGs in our data set. And we also did that for reducing inequality. We have visible features such as, and we also have for clean water and sanitation, we have visible words such as water, river, groundwater, environmentals. Basically, all these words are going to be used by our model to actually learn and be able to predict or classify text. And these visible words give more meaning to our model. And then going forward, we actually could have placed this at the end of the project, but to put our insights all together in one, we work on the shared data, which our data engineer was able to scrape. And then we use the model to predict each of those articles and look at the frequency of how shared has been able to achieve, or how they have been working with the SDG goals in aligning it with the 2017 goals that they set out to achieve. And we can see that only like 3 or 4 are being more focused on, and which can inform them on what to do next or the way forward. And moving on, to go to the modeling proper, we first of all work on the feature engineering. And here what we basically did was did the upsampling of our data set. Since those of our SDG goals were not balanced, we did an upsampling, and this was done because after various experiments, we realized that upsampling is better than downsampling. And we also set our maximum features to 20,000. That is all the text that we have in our document, which are going to form the features, which will be used to train and which will be used to predict. We set it to 20,000 so that our computing power will be able to handle it. And when we also deploy to the cloud, it will be faster and smoother. Then we also used inverse document frequency for our vectorization. That is why we are trying to turn the text into numbers so that our model can make a sense of it. We use inverse document frequency. That is, the lesser the word, the more important it is to inform our model. And going into the modeling aspect properly, we try to lay our hands on all the classifier that we can get and that our computer can actually handle. And we pretty much work on all these classifiers that we have here. And for the evaluation, we use the F1 score, which take into account two other metrics. And after some experiment too, we realized that F1 score is a better evaluation for this particular project. And we did a cross validation of 5. That's basically mean we did an experiment of 5 on each of the models, and we are able to come up with a box plot to represent each of those classifiers. And we see that linear SVM on the top, the far right, perform better than any of the classifiers that we have. And moving forward, we use linear SVM after doing some research, which basically means that we did an hyper tuning to have a better model using the linear SVM. And I will now hand over to my other colleague, Cedric, to take us through the project architecture. Thank you.
Okay, thank you, Emmanuel, for this insight. So we'll now, after talking about this introduction, the problem, what we are solving, we'll now see how exactly we've been able to tackle our issue and then solve it. So our problem was divided, or the development was divided into two groups. We have the machine learning aspect as well as the application aspect. So we'll first start by discussing the machine learning parts and then move to the application itself. So talking about the data, the machine learning architecture, any ML project or data science project requires data. So we first gathered our data, and then moving from this step, we had to explore the data to be able to understand it. And from the previous people who introduced the Saturday presentation, we can see that we went deep to see the distribution of the various goals we had. We had a look at on the word class that were also associated with the various goals. And after that, we went through some cleaning because the data we had was not clean. Since it's a natural language processing project, we had to operate and act according to the structure of how to clean it text data. And then we moved to the data engineering. There was a need to balance the data. And we saw with the graph that was displayed that our data was not balanced. And we had to upsample the data to be able to move to the next step, which is the modeling. And in this modeling aspect, as shown, we use various models. We try our hands on various models to be able to get the best one. And to evaluate our models, we use the evaluation matrix, which is the F1 score, which has allowed us to get our best performing model, which was the linear SVM. Now we'll move to the second architecture, which is KEDRO. Before we start discussing the architecture, we'll explain in few terms and simpler words what KEDRO is. So basically, KEDRO is an open source Python framework that helps machine learning engineers as well as data engineers to be able to develop code that are maintainable, that can be reproduced, and that can be easily deployed using some specific principle that have been borrowed from software engineering. And we have versioning and modeling as well that are also embedded in this framework. So now that we have a fair idea of what KDO is, we'll now dive deep into our architecture understanding. So now we have mostly two colors here before we start. We have the pink color, which represents the data, and then we have the processes or the method, which are in blue. So as we mentioned, everything starts from our data. So we had to collect the data. And then after collecting the data, we had to pre-process the data. So that happened in this node where we have the pre-process methods that will take charge of preparing our data and making everything ready. And the output of this will be the pre-processed data set. Now, having our data pre-processed and everything ready, we have to split our data into three to be able to move to the modeling aspect of it. So after splitting the data using this specific node, we got three outputs, which are the X-ring, the X-ring, and then the Y-ring basically will be used to train our model so that they can learn, the model can learn from the data we have. And also we have our X-text in the middle, which will be used to test the model and then evaluate the performance of the model as well. And then these three output that becomes now input, we now put into the vectorizer node, and the vectorizer will process all the three inputs and then give us the output. So we'll now have our X text that is vectorized as well as the Y train, and then we'll have our vectorizer. So moving from this step, we'll now move to the modeling aspect. So now that our data is prepared and ready to train our model, we'll now put it in the training aspect where, sorry for that, in the training aspect where the model will now learn from the data that we have. And then from there, we can now have our classifier ready to classify any other test. Now, in case we want to now use, in case we want to make a new prediction, we have to input a new text or variable that will now be vectorized. And then based on that, we can now insert it in our model and then do the prediction. And as we mentioned, we also use an evaluation matrix. We've been able to evaluate our model based on the Y text as well. So now, after talking about the architectures, we'll now move to the application demo. And then our application was deployed on an EC2 instance, and the model was in the S3 bucket. So this is where all this work led us to, the Streamlit application, which is our solution. So first of all, the first part we would like to discuss is this interface that we have, where we give the user the option and the possibility to have a view of the various SDG that are available. And this can also inform them on where they can lie their interests. So as Shell being an energy company, they can take out all the SDG goals that are related to energy and then climate, because energy has an impact on climate. And then from there, they can now make decisions on how to achieve those goals. After this first feature, we can move to the most important part of our work, which was to be able to give Shell a solution that will help them reduce the time used to make prediction and also avoid bias, because our personal beliefs can affect how we classify a text. So this is our solution. To make it live and then to make a demo, we'll take an article that was provided by Shell, and then we will predict the article using our model. So I will copy the article. And this article is related to the war between Ukraine and Russia, which has affected the cost of all the product that Shell provides. And then their aim was to find a way or solution in order to make it available to everyone. So now let's see what our prediction will be with regard to the article we have. So now we can see that the output is SDG 3, and then it seeks to ensure healthy life and promote well-being for all ages. And that, in fact, is related to the article, because Shell, in this article, was trying to find solution on how to come out in this crisis to ensure that everyone has access to energy, everyone is being able to operate and live in a more effective and equal manner. So now you can put any other text. We will use another article from Shell again to make the second prediction. Okay, so we can see that this article is more related to gender equality. And another thing to mention in this application is the fact that you can click on this specific image, which is basically an hyperlink. And this will take you to a page where you can have more information related to that SDG goals. And based on your network speeds, you will have a page that gives you more details and insights on that specific SDG goals, how you can acquire them, how we can reach them, and then have more information. So this is the page of the UN where we can go through and then see the goals, understand them further. So we'll now move to the next part of our application. Our data engineers have been able to scrape data related to Shell from various sources, and then we've used those data to apply our model on and be able to make some predictions. So this is the results of our predictions using our linear SVM model. And we can see that, in fact, Shell is more focused on energy, climate action, and also sustainable cities and communities. And we can relate that to Shell because Shell is an energy company, and then they are having more impact on these various SDGs. And we also have a table here that gives a representation or a tabular representation of our model and then the results as well. So we can see that for SDG goal 7, which is basically affordable and clean energy, there was 664 articles that were related to that specific SDG goal. And then the same goes for the rest of the model. So any data set that is uploaded to this model or this application, it will be able and possible to generate this information. I will now hand over the presentation to my colleague Marshall, who will conclude our presentation.
Awesome work, Cedric, and that was really great walking us through the technical parts of our project. And at this point, I'm going to be walking us through some of the highlights of our projects by way of conclusion. And I will be starting with the achievements. And personally, I think the most important highlight is the fact that we're able to create a solution that would assist people, companies, governments, and in this case, Shell, with keeping track of their progress on their preferred SDG goals and targets, as well as helping them see areas that require more attention. And the best part is all of this, as was shown in the demo, can be done within seconds with an accuracy of over 80% by a single person using our application. And by the time you put this in contrast to the conventional system of reporting, which includes a team of several experts and painful hours of deliberation, we can say we have indeed solved the problem. And as Salvador Dali once said, have no fear of perfection because you will never reach it. Our solution also couldn't attain that lofty height of perfection, and some of its major flaws, I'm talking about its weaknesses, include the fact that it couldn't source for its own data. And our team of data engineers had to do, like my colleague mentioned, a lot of web scraping in a different environment, totally different from the application, before feeding that script data that was used to train and test the model. Also, there are limitations by way of data visualization options provided to the user for the user to gain more insight into the data. And finally, the last thing I would want to highlight on this topic is the limitation to how data can be fed to our application. And this being the first version and all, the application can only accept plain text for analysis and prediction. And that is something we hope to improve on in the future. And also, as this initial version of the application has been completed, this is my team recommendations. We had a few ideas for continuity's sake, and some of which will go on to address some of the weaknesses and limitations I mentioned earlier. starting with making the application a multi-label classifier. Because at the moment, like you saw, the moment was built and designed to only make single label predictions. So like when he pasted the text and then it came out as gender equality, we believe that that article wasn't only talking about gender equality or good health and well-being. And we were hoping that probably in future versions we'll be able to pick out other labels in order of their importance as to what the article is pointing at. And another good feature to implement would be the ability of the application to source for its own data. So for instance, a user will just need to type in a company's name, for instance, Shell, and the application takes that as an input to source articles related to that company, analyze, and then make predictions based on the data it got. And lastly, we feel it would be absolutely awesome if after all this, subsequent versions of this application could also recommend certain strategies that would enable the user achieve the goals in which they were lacking, in those areas which were lacking. And this brings me to the end of our presentation. However, I would like to end with a quote by the first Black president of the United States, Mr. Barack Obama, in which he said, and I quote, "Change will not come if we wait for some other person or some other time. We are the ones we've been waiting for. We are the change that we seek." It is the sincere hope of the entire team that our application, in whatever little capacity, will play a positive role in achieving the UN SDG goals come 2030. Thank you very much.
I mean, the floor is open now for any questions. All right, cool. If there are no questions, I have one question for you, Timsy. I mean, in terms of working on the project as a whole, how easy or difficult was it collaborating with other teams to achieve the single application?
Okay, I'll go for this. So there was a part in the process of developing the project where we had to get some information from various teams. And especially during the modeling aspect where we had to collect the various notebooks that were available, merge them together, and then get the best performing model. So the small challenge is not really a challenge, but it was a part where we've all been able to learn as well, where we had the teams, the various teams, schedule meetings with them, and then they took us through their modeling aspect, how they understood the project and how they approach it. And based on that, we've been able to generate our model for this project. And I think it was an awesome journey that helped all of us learn a lot in the process.
Yeah, to add to what you just said, my name is Mark Matthew. Then during the project, I think the mentors actually gave us a head start by giving us a plan to work on Kaggle and work on a collaborative notebook, and then gave us an opportunity to work on Docker, helping us to see the difference when you collaborate differently and try running programs like your libraries and they don't work, and you go to Docker and you find out that you don't even have to pip install anything. You just run your programs and it comes out. So it's like giving us a problem and later giving us the solution after, helping us note the difference. So that's why collaborating was quite easy for us. Yeah.
All right, cool. And I think I have one question about the labeling. I mean, why do you think that at the moment, like automated labeling systems do not exist and people prefer more using like what do you call this, experts in the field to come together and label the data set, like what was done with your original data set?
Can you come again on the question?
Oh, I'm saying, why do you think at the moment that automated labeling systems do not exist and people still prefer to have specialists labeling the data set?
Okay, I'll start. Maybe a colleague will continue. There is this perception and idea that systems are prone to error. And then people to transit and move to the technology, to using technology solution, sometimes it's hard in some companies who are a bit not ready to use and then embrace those technology. So this can be a reason why people are not going for this type of solution. And even after developing this type of solution, the next step it will be like if we have to sell it to other companies, we have to find a way to convince them that this solution is better than what they are having by giving the strength of our solution. And I think that's one of the reasons.
Thank you for that, Cedric. I see Kwazi also has a question for the teams. How was it working with DS and DE? What challenges did you face and what did you learn from each other?
There's a question.
I mean, anyone can take the question.
Yeah, I think this question will even be more better for the DE, that the data engineers to even answer, because at the first stage of the program, the DE were complaining that they had nothing to do because the first stage was it's like rigged for just data science alone. But based on the mentors, I think it was also a kind of a setup to actually get us to know one another and contribute individually. So when the main project started up, the DE were so bombarded with projects and workloads that they started sourcing for help from the data science. So it actually helped us collaborate more. That's the first stage of the program.
Thank you for that, Matthew. Are there any other questions? I mean, I think if not, okay, cool. Kwazi, you're on mute. Nothing is coming through, Kwazi. All right, I'm going to assume that Kwazi is having.
Can you hear me now?
Yes.
Okay, so since the team is more familiar with the data, what would you guys do differently if you were to continue working on this project? Like, what improvements will you continue working in the same manner, or will you include more sophisticated ways of working?
Okay. So I think with the guidance of our mentors, we've started developing the project on a good roadmap, and then everything the roadmap we followed is great so far. Now, what will change in our project specifically is what we mentioned in the recommendation part, especially the multi-label feature, because an article can have more than one label, and then it's important to know all these models as opposed to knowing only one label that's associated to that specific article. And that can help Shell a lot, because before they do any publication or before they publish anything, they can at least put their article or whatever they want to publish to our solution, and they can see all the labels that are associated to that article and now compare it to the 6 SDG goals that they plan to achieve in 2017. So this is the main thing that will change, and also allowing the user to upload new data set and then be able to make prediction based on that data set.
All right, cool. Any other questions? Cool. I think with that said, that brings the end to the teams that were working on the UN SDG Global Sustainable Goals. Thank you for all the teams for contributing. I mean,